This video is a follow-up to the previous YouTube tutorial about how to calculate standard deviation, mean, and some other chatter about variation by hand. But today we're going to be talking about how to do this in Excel and R, which is so much faster. So let's start off in Excel. And let's pretend for a moment that we are scientists looking at kangaroo jumping height. So maybe this is in feet for this particular example. This is just dummy data that I made up. To calculate the average, you write in equals average and then select all of the observations in your sample, close the parentheses, and then you get an arithmetic mean. Super easy. What if you want to calculate the median, the middle value? Easy as pie. Write in equals median, select all of your data, close the parentheses, and you get your median. What about standard deviation? Kind of tricky to do by hand, super easy to do in Excel. Same sort of thing, using the programming equals stdev, select all of your data, close the parentheses, hit enter. It's perfectly acceptable that you use anything that we're going to go over today to calculate these values, but you should understand the basic mathematics behind how you get each of these values. If you want to see what else Excel is capable of doing, feel free to go to the formula builder. So for example, mode, it gives you information about how to calculate that value. But there are some things that Excel isn't as good at calculating. For example, interquartile range. There are ways of getting around that, but it's above and beyond the scope of this particular tutorial. But suffice it to say, this is actually really easy to calculate in R. So what I'm going to do now is delete all of the things that we just put in here because we are going to import this data set of our sample data of kangaroo jumps into R. And if you recall, we need this to be a nice, easy .csv file. So you'll see that I have this folder on my desktop, and for some reason it's not showing up with the file extension, so I'm adding it. Jumps.csv. Then I'm going to open up RStudio. And this is just some stuff that was already in my working directory, so don't worry about it. But you'll see here that this is a script that I have referred to in class. I'm going to keep it up here because I'm actually just going to paste and copy some code that I've already written. I absolutely encourage you to save your code as you go along because you can always refer back to it. Go up to Session, go to Set Working Directory, find the folder that has your file in it and open it. And you'll see here that the correct code pops up in your console. And then I'm just going to load up the library ggplot2 in case I want to make any sort of plots. And then the next step, now that R knows where to look for our file, is that we actually need to get our file into RStudio. And so I'm just going to manipulate some code that I've already written here. So instead of stereotypes, I'm going to name this variable or this data set jumps. And then I'm going to change or update the name of my file. So jumps.csv refers to the exact name of the file that is in the working directory. Jumps.csv, jumps.csv. So we are good to go. And then go ahead and click, and then the header equals true. If you recall back, I'm just going to pull this data up to illustrate. This means that the first row of our data actually has information about the categories, or for that matter, the continuous data below it. And then separator is a comma because we're dealing with a CSV file. So we imported our data. Looks like it's all there. Nothing looks weird. So we're going to go back to our code here. Just seeing if there's anything else we can use. Nope, but that's all right. So the first thing that we're going to do is calculate the mean. To do this, you type in mean, and then you would think that maybe you could just type in the name of the data set. Unfortunately, no. You need to tell R specifically which column you wanted to look at. And to do this, you write in the name of the data, and then a money sign, and then the name of the column. So do the same sort of thing to calculate the median. Again, telling it the data set before the money sign, and then the column header after. Let's try IQR, that interquartile range. Really easy to calculate in R. Standard deviation, same sort of thing. Oops, looks like I forgot the code for this particular function. No problem though. There's a ton of documentation online. So if you just calculate, or you type in how to calculate standard deviation in R, you will get the function name as well as a full explanation many times over. I really cannot encourage you enough to use Google to figure out how to improve your coding knowledge. So now that I know that it's just SD is what RStudio interprets standard deviation on, again, writing in the name of our data set, money sign, and then the column header afterwards, we easily calculate our standard deviation. So what about standard error, another type of measure of data spread that we're going to be learning about next week? This one's a little bit more complicated. So again, we can pull up some information here, but this is a little bit trickier. So we're actually going to push this off to the next tutorial once you get a little bit more familiar with using RStudio. Again, consider maybe trying to figure out how to calculate variance. Very easy. We just use the var function. So type in var, and then the same thing that we've been doing all along. Perfect. Really easy.